Hello dear students. So today we are going to study about the photoelectric effect. Do you know Sir Albert Einstein received Nobel Prize for his works on the photoelectric effect in 1922, though he gave his theory on photoelectric effect in 1905. So what we learn from the stories of famous people is that कि मेहनत का फल मिलता ज़रूर है, तुरंत ना सही, थोड़ी देर से सही, पर मिलता ज़रूर है. Now, why are we going to study about the photoelectric effect? Some of you might say, sir, we need to score good marks in exams. It's part of our syllabus. Well, then I'd say yes, that's correct, but that's not the main reason why we are studying here about the photoelectric effect. Well, we all know light. It's because of light we are able to see things, objects around us, the world, the beautiful, colorful world around us. We are able to see it because of light. But do you know that light is actually a small portion of a big family of electromagnetic radiations? Let me give you a few examples of electromagnetic radiations. You must have heard about radio waves, microwave oven. Yeah, it works using microwaves. Infrared waves or heat waves, then light obviously, then ultraviolet waves or radiations, which comes from the sun, right? Ozone protects us from the ultraviolet radiations. Yeah, we know that. Then we have X-rays. Then we have gamma rays or gamma radiations. In nuclear reactions we have heard about gamma radiations. Okay? So these all famous examples are actually the member of a big family of electromagnetic radiations, of which light is only a small part. Now these electromagnetic radiations have dual nature. The first nature, let's say, is the wave nature. So these electromagnetic radiations behave as waves. Well, there are few effects or few phenomena which can only be explained when we consider the wave nature of these electromagnetic radiations. Let me give you a few examples. Interference, diffraction, polarization. These effects of phenomena can only be explained by using the wave nature of electromagnetic radiations. Now the second nature of electromagnetic radiations is the particle nature. What does that mean? It means that these electromagnetic radiations behave like matter particles as well. Like there are electrons, there are protons, there are atoms, molecules. These are matter particles. So the electromagnetic radiations also behave like matter particles. And this photoelectric effect is a very fine example of the particle nature of electromagnetic radiations. So let's go into the depth of this topic, the photoelectric effect. Before we go into the depth, we need to understand a very basic term, that is electron emission. Now, what is an electron emission? Let's consider a metal surface. Let's say here we have a piece of metal. There is this metal surface on the top. We all know that metals have free electrons inside them. These free electrons are continuously or incessantly moving from one place to another. They are under random motion because of their thermal energy. Let's say one free electron tries to escape the metal surface. What will happen? Initially this metal surface was neutral. Now a negatively charged electron is trying to escape the metal surface. This is a negatively charged electron. So if the negative charge moves out of the neutral metal surface, the metal surface will acquire an equal and opposite positive charge. Now due to Coulomb's force of attraction, this electron will be automatically pulled back towards the metal surface. So this free electron cannot just leave the metal surface on its own, but electron emissions are possible. Free electrons can leave the metal surface. Yes, it's possible. So when does that happen? To understand that, we need to understand or know about the term work function. It is denoted by the symbol phi naught. Now what is a work function? Work function is defined as the minimum amount of energy required to pull out the least bound free electron from the surface of any metal. Understood? So if we supply, let's say here is a free electron, somehow by suitable method we are able to supply this minimum energy, that is work function, to this free electron. Then this free electron can come out of the metal surface and it won't be pulled back towards the metal surface. Yes, that is work function. Now work function for different metals has different values. You could say it's a characteristic property of metals. Let's take the example of platinum. Platinum has the work function of 5.56 electron volt, whereas the metal cesium has the work function of 2.14 electron volt. Platinum has the highest work function and cesium has the lowest work function. So it is the easiest to pull out a free electron from the surface of cesium metal, and it is the hardest to pull out a free electron from the surface of the platinum metal. Ionic emission. On the basis of the method of supplying the energy, we name the electron emissions accordingly. So the first method is thermionic emission. What we do in this method is we suitably hit the metal surface. When the free electron gains the required amount of energy, or when the free electron gains the energy equal or more than the work function, then the electron is emitted. So this is a thermionic emission. Very basic. Number 2, field emission. So in this field emission, the second way of electron emission, we apply an electric field of very high strength or magnitude across the metal surface, and the free electrons are pulled out of the metal surface, or the electron emission takes place. The electric field required is of the order of magnitude 10⁸ volt per meter. So this is the order of electric field required for the field emission to happen. Then the third method is photoelectric photoelectric emission. In this method, what happens is when light or radiation of suitable frequency falls on the metal surface, electrons are simply emitted. The electrons so emitted in this method are known as photoelectrons. Why such name? Photo means light. So basically these electrons are generated because of incident light. So light generated electrons are known as photoelectrons. Okay, so these were the three methods of electron emissions which take place.